Okay, this is the TYS for the bonding chapter, ionic bonding and covalent bonding. This is on section B, essay question. Now this is year 2003, paper 3, B8, section B, question 8. Now describe using one suitable example the formation of ionic bonds between metallic and non-metallic elements. So you have to describe and you have to give an example of the ionic compound. Now ionic bonds basically form between metallic and non-metallic elements. So from your periodic table, the metallic elements would be on the left hand side. Basically it's on the left hand side of the staircase, and of course the non-metallic elements would be on the right hand side of the staircase. The staircase is here. Okay, this is the staircase. On the left hand side of the staircase are the metallic elements. On the right hand side of the staircase are the non-metallic elements. So you can just pick any metallic and non-metallic element, and the easiest example would be the common ionic compounds, which is sodium chloride, Na, which is sodium group 1, and chloride group 7. Now for this question, what you need to do is to describe the formation of ionic compounds. So first, we already know that ionic compounds are formed between metallic and non-metallic elements. So how do they form? So it is formed by the transfer of electrons. So you can draw the dot and cross diagram to illustrate how the formation takes place. So sodium, draw the dot and cross diagram. Sodium, the dot and cross diagram, you need to know how many electrons there are. So the bottom number basically is the proton number or the atomic number, which is the number of protons, and for an atom the number of protons is the same with the number of electrons. So for sodium atom, number of electrons basically it's 11. So 11, the electronic configuration is 281. So 281 means there are 3 electron shells. Okay, first shell 2 electrons, second shell 8 electrons, third shell 1 electrons. And then for chlorine atom, the number of protons or number of electrons is 17. So 17 is 287. So chlorine 287, meaning that there are 3 electron shells. First electron shell 2 electrons, second electron shells would have 8 electrons, and the third electron shell would have 7 electrons. So what happened for the formation of ionic bond is this, the valence electron of the sodium atom would be lost. Okay, so the sodium atom loses an electron to become sodium ion. So what it becomes now since this electron is lost, it will become a sodium ion. So now the sodium ion would have only 2 electron shells, because when the valence electron is lost, the third electron shell is lost. So now it has only 2 electron shells, and when 1 electron is lost, it would become a positive ion, like that. And the electron lost would be gained by the chlorine atom, because the chlorine atom has 7 valence electrons short of 1, so it would gain the extra electron in order to be stable. Likewise, for sodium atom just now, it has 1 valence electron, so it tends to lose the valence electron to become stable to 8. So now, after gaining the extra electron from sodium atom, the chlorine atom will become chlorine ion. And the chlorine ion, same with the chlorine atom, it would have 3 shells, except that the third shell would have 1 extra electron, which is from the sodium atom. Okay, and after gaining the extra electron, it will become chloride ion with the charge of 1 negative. Okay, so using this drawing, you can describe. So how do you describe? You just have, so I'm just going to write it down in point form. The sodium atom loses an electron to become sodium ion, which is Na plus. This one is Na. Then the electron lost by the sodium atom is taken up by the chlorine atom to form chloride ion, which is Cl negative. And then after that, the transfer of electron. Basically forms the ionic bond. Okay, these are the key points. Transfer of electron basically forms ionic bond. So that would take care of the 4 marks. These are the key points, but of course you cannot write in point form. You have to make it into a paragraph. Okay, let's go to part B. Explain why ionic compounds have high boiling points and most covalent compounds have low boiling point. Now, ionic compounds. Why ionic compounds have high boiling point? Now, this is because ionic compounds consist of, this is from your ionic bond mind map. Ionic compounds consist of positive and negative ions held together by strong electrostatic forces of attraction. Okay, and these electrostatic forces of attraction is very strong. Therefore, large amount of energy is required to overcome the force, and because of that, it has high boiling point. Okay, so for part B, you need to say ionic compound consists of positive and negative ions held by strong electrostatic attraction force. And because the electrostatic attraction force, and this electrostatic attraction force is between the positive and the negative ion, it's very strong, and because of the fact that it is strong, you need to have large amount, okay, this is amount, large amount of energy is required to overcome it. And because of that, it has high boiling point. Okay, that is for ionic compound. Now let's talk about covalent compounds. Why does it have low boiling points? Now this part, it's from here. It's from the mind map of your covalent bond, covalent compound. Now covalent compound, for example, CH4, it consists of simple molecules. This is one CH4 molecule, this is another one, this is another one, and all these covalent molecules are held together by weak intermolecular forces or weak van der Waals forces. And this van der Waals forces is weak, and therefore little amount of energy is required to overcome it, and because of that it has low boiling point. Okay, so you have to say covalent compound covalent compound consists of simple molecules, and these simple molecules is held together, held by weak intermolecular forces. Weak intermolecular forces. And because the intermolecular forces is so weak, small amount of energy is required to overcome it, and because of that it has low boiling point. So when it explains why certain compound has high boiling point, why certain compound has low boiling point, you have to explain it in this order. First of all, explain the structure. What does it consist of? And then you have to explain the forces. What force that keep them together? Then if the force is very strong, you have to say large amount of energy is required to overcome it. And because large amount of energy is required to overcome it, the boiling point must be high. That means you need to heat it very strongly until a very high temperature in order to overcome the force. Okay, so this is basically step-by-step explanation how to explain whether certain compound has high boiling point or low boiling point. So the two types of forces: strong electrostatic attraction force, weak intermolecular forces. Weak intermolecular forces is for covalent compound. Strong electrostatic attraction force is for ionic compound. Now one thing to take note of is the intermolecular, for the covalent compound, the intermolecular forces are very weak. In between the molecules, like this dotted line. This dotted line basically depicts the intermolecular forces, and it is very, very weak. But in between the carbon and the hydrogen atom, in between all this carbon and hydrogen atom, the bond is covalent bond. So the covalent bond itself is very strong, but the intermolecular forces that hold all the covalent molecules together are weak. So there are two bonds here, two things here. One is intermolecular forces, which is very weak, and the covalent bond which is very strong. Okay, so do not say covalent bond is very weak and hence it has low boiling point. That is wrong, because what determines the boiling point of covalent compound is the intermolecular forces. For simple molecules, what determines the low boiling point basically is the intermolecular forces, which is very weak. Okay.